AI is not going to replace humans, and it shouldn't. Instead, AI and human should work together as partners. My name is Felicia and I'm from Visual Sweden, and today we will talk about augmented intelligence and tangible interfaces to AI together with the assistant professor in interaction design and visualization, Ahmet.
Yes,
Hi, Ahmet.
thank you. Hi, Felicia.
Please explain, what is a tangible interface?
Yes, maybe first we should talk about non-digital tangible interfaces. So here we have an hourglass. We don't use it so often nowadays, but it still works. And this hourglass, the sand inside, represents time. And we understand how much time we have by looking at it to complete a task. So it's kind of setting up a timer. So this is actually the first advantage or characteristic of a tangible interface. It physicalizes an abstract concept or information so that we see it in a concrete way. And the second part, the second advantage or characteristic of tangible interfaces here is that the sand represents the time without showing us any numbers. So it does not use any written or symbolic information to communicate the content to us. But instead, we use our existing knowledge of the world, existing knowledge of the physical world. And this enables us to understand how much time passed so far or how much time actually we have ahead of us. So the third advantage or characteristic of a tangible interface is that it does not require us to learn new information. So which button does which task kind of, but we understand it through the physical structure that it offers us. So in this case, if we want to set a new timer, we just turn the hourglass upside down because this is an action or a consequence that we know through our countless encounters with the physical world. We know how the physical materials work. In this case, when we turn the hourglass upside down, we know that the sand will pour down, start pouring down, and that will set a new timer. So it actually uses real-world metaphors that we are extremely familiar with. And this also enables us, not to use any labels to say that you should do this or instruct people.
So this is a way of using our intuition rather than getting instructions or digital numbers to understand the world.
Yes, exactly.
Okay, but now how could we use this when interacting with AI?
So now maybe we have a better understanding of what digital tangible interfaces are. So digital tangible interfaces are physical objects coupled with digital information or data. So when we interact with a digital tangible interface, it enables us to manipulate this information or data. And when we look at it, we see actually how the data changed or the information changed and what is happening or what happened in the system. So when we come to let's say interfacing AI or tangible interfaces to AI, we can say that a tangible interface or a tangible AI should be such that it physicalizes, it makes it concrete, the abstract existence of AI. So this is the first thing. And the second thing is that it should, the AI should enable to tell us what it is doing through physical expressions. So not only through screen visualizations or voice interaction. And the third thing is that it should have a physical embodiment that enables us to ask or tell things to it. So to interact with it. With our whole body by using hands, legs, or etc.
Okay, so it could kind of give you physical feedback. For example, if there's an emergency, it would shake, or if it's business as usual, it would move rather smoothly.
Right.
Okay. So I understand that you have done studies in this area, both internal at Linköping University, but also with companies. And together with Toyota, you explored a partly autonomous luggage handling system. Could you tell me a bit about that scenario?
Yes. In that project, we explored the future of autonomous warehouses in the context of baggage handling at an airport. And the concept was about control room operators overseeing and interacting with AI predictions to control and monitor the baggage flow and also maintenance of relevant equipment at the airport. And the concept enables operators to preview current and predicted system performance regarding baggage handling. So the operator has in front of her 3 screens in the control room, like you see like in the video, and she has a tablet in her hand where she can see all 3 screen content on it as they are positioned in the space. And she looks at these screens to understand what is going on. For example, in the middle screen, we see here, at 5 p.m., she sees that there might be an intervention required. If she should take care of the situation because there will be some need there to manage the baggage handling, baggage flow. And what we see in the center screen is the blue line, which represents the predicted performance, predicted available capacity. And the orange line represents the predicted required performance at certain point in time in the future. So when she looks at these, she can understand from the relation that what will happen. And on the right screen that we see here, there are countermeasures suggested by the AI. So there are actions suggested by the AI to take to solve these conflicts. And on the left screen, you can see the planned and executed actions. So there are 2 key points in this concept. The first one is that the operators are able to see current and predicted system performance through visualizations. And the design of this system enables them to see these future states in the system. But at the same time, they still maintain a situational awareness, so they know what is going on in the present, which is important. And the second point is that they can preview the consequences of the actions suggested by AI, like the ones we see here. And they do this without affecting the existing actual airport operations.
So like a simulation?
Yes, exactly. Like a simulation that they do within a sandbox, in a sandbox environment, so to speak. And of course, this is important because not all the actions suggested by AI mean that they will work. So they can try out some and see what consequences they would have, and then only, they can intervene or execute that action. And this, I think, says also something about what we mean by augmented intelligence. So combining human intuition and intelligence with what AI can do and its capabilities.
Okay, so keeping the human in the loop in decision making,
yes.
Even though you get decision support.
Yes, exactly.
Okay. So I think this is a quite concrete way of demonstrating augmented intelligence. And I guess the concept could be applied in many areas. Let's say AI-assisted manufacturing planning in the manufacturing industry, or piloted at sea, or maybe even in urban planning.
Right.
What do you say? What was the key points that you learned?
Yes, it was a valuable experience working with Toyota in this project because it enabled me to have a deeper understanding of what AI is and what it can do and how actually it is expected to work in industrial settings, this human-AI collaboration. And it helped me to think about this collaboration in a more realistic way So it enabled me to think about more realistic AI cases and also structure better scenarios for human AI or agent collaboration. And also the Toyota project enabled me to understand how multimodal interaction is important when it comes to AI, because multimodal interaction means using different modalities, so different sensory channels. And using the visual channel together with, let's say, a haptic channel, so tangible interaction, actually could be very helpful in this case, because we are talking about huge amounts of data and information that can probably not be put in a single screen or even in multiple screens only. So if we can represent some of these information through tangible objects, this can help us maybe create calmer work environments, because we can reduce maybe the cognitive load on the operators or anyone interacting with AI in those kind of environments. So this is another research area I am involved in.
Okay. Oh, yeah. You have explored this movement-based and human-agent interaction, and we have a video of this. Let's have a look at that, and
Sure.
you could tell us what's going on in the video.
Yes. Actually, in this video, there are two things. One is the study that we did to explore how humans can interact AI in this way by using the sense of touch. And the second is the Wizard of Oz mechanism that we built to do this study. So let me first talk about the study. The study is based on a phenomenon, actually. As humans, when we look at objects move, when we see them move by some external force, we tend to think that they are kind of living creatures, even though they are only inanimate objects. Because when we see these movements, we attribute personality and agency to them. Like the plastic bag in the movie American Beauty, where the protagonist, when he sees this plastic bag moved by the wind, he thinks that he was dancing with him. It was dancing with him, even though there was no, of course, like living thing that wanted to dance or anything. But that's our perception. So this is interesting. And when an AI or a robotic artifact mimics human form in a very realistic way, our expectations become so high in terms of social interaction. But when we see that actually they do not interact as we expect, like humans, when it's not that fluent, for example, this creates awkward situations and feelings. But when we see an AI or a robotic entity, robotic artifact that do not resemble humans or human form, but it's just like an ordinary object, our expectations are so low. But once we see them move around, go around and come close to us, we think that they are trying to tell something, actually. So this is a positive mismatch. And they become, in a way, behavioral objects in this way, as mentioned in the literature. And this is an interesting thing, because it opens up some avenues of research that could be helpful for human-AI collaboration.
Okay, so this is really an aspect to take in consideration, and not seeing the AI as something with its own spirit, but rather as an agent in any form.
Yes, exactly. It can come in any form, really. So, indeed, in this, as you see in the video, in this study we used a small handheld robot that do not resemble humans or does not have a human form. And Marcus Jessen, a master's student in cognitive science, planned and conducted this study where we wanted to compare two different modalities of interaction with this AI. One is through direct touch via hands, by using hands, and by interacting with it through a graphical user interface on the tablet. And we wanted to understand how direct touch actually influences our sense of agency in such a collaboration. So in other words, how much we feel in control while we are interacting with AI, we are collaborating with AI. And for this, we designed some motions, basic motions for this robotic artifact, this AI. So, for example, one motion was that it was rotating while the participant was interacting with it. And it was trying to hint at some directions to complete the missions they were given. Because in this study, the AI and participants were teaming up to complete some objectives. And AI, for example, was hinting at some directions so that they could achieve the mission. And another one, for example, that the AI could resist to the participant when he or she wanted to go to a certain direction. So we wanted to introduce some agency in the interaction. And we wanted to understand how participants interpret these motions in terms of interaction, agency, and collaboration. And the preliminary findings show that direct touch could be helpful in having kind of higher level of control respect to the graphical user interface.
The tablet.
Exactly, respect to the tablet interaction, and also can be used to get more detailed information about the situation, for example. And graphical user interface seems to be more suitable to have an overview of the situation.
Okay. You talked before about the Wizard of Oz, and I think we saw a glimpse of that in the video. Tell me more.
Right, exactly. So this, so Wizard of Oz, maybe I should first explain what it is. It is a method to understand how a concept or a not working prototype actually would feel and look, even if it's not working, even if it's not implemented. So how is this done? This is done by humans. So instead of we putting a robot here working on its own with an algorithm, we use a human, we introduce a human. A human controls the robot behind the curtains. And this, of course, allows to save time, effort, and energy. Instead of working on the implementation on a concept that you might not know how it will work, if first you explore it through this way. And here, actually, as you see, it was me, that human, that controlled the robot, that did the wizardry. So I was under the table and under this custom built table, and I was using a controller made with strong magnets, and this controller was being attached to the robot, and I was able to steer it. And all the participants except one actually didn't understand, thought that the AI was actually working on its own. There was an implemented AI. And so the setup actually worked. So it seems that it's a useful way to explore these kind of settings in real time.
Yeah, okay. But why would we actually need this kind of mechanism?
Yes, we would need that to quickly explore possible interaction techniques with this kind of AI entity, but also to quickly try out possible scenarios, collaboration scenarios, for example, where there is a human, let's say, operator and this AI, how that scenario would play out. And you can try this out in real time without any high-tech equipment. But this is a low-tech thing that helps you to do this.
Right.
And there is another actually important aspect, I would say here, a potential, I would say, is that this Wizard of Oz mechanism can be also used with a partially working robot or AI, which would enable, for example, the actions performed by the human wizard to be recorded in a log file and then translated maybe in an algorithm. It can be used in developing algorithms.
Okay. But what areas do you see that could benefit from multimodal interaction?
Yes, it can benefit. One area is, like you mentioned, urban planning, for example. So combining two different modalities and channels like visual and haptics and tangible interaction, urban planners or people who study urban planning can use that to have a different impression of the urban environment. So instead of just seeing, let's say, a noise pollution data, which is normally invisible, they can, while they are looking at it on a screen, they can also feel it by their hands, how the situation feels. So it's more of a feeling and visceral connection with what is happening in the urban environment, rather than just seeing it and thinking about it rationally. So this could really benefit the relationship, can change the relationship that urban planners have with the urban environment. So it could add another dimension to that.
Yeah, okay. And thank you so much for explaining this. My final question is, what are the big obstacles? You have overcome some of them, but what are really the big obstacles?
I would say the technical threshold is a big obstacle because it is so high that it's not easy to understand how AI works or what an AI can do. So maybe it's a better starting point for projects to first understand the context in which an AI can do its thing, like can work or collaborate with us, and then create a desired future scenario in which we imagine this AI interacting, collaborating with humans. And once we have this vision grounded on realistic expectations, then it would probably be more productive and easier, like more focused to design AI or AI entities or AI interactions. And this requires a joint work of researchers, technology developers, and industrial partners. And we are always open for collaboration in these kind of projects.
Thank you so much. And thank you to everyone who listened. If you want to know more or come in contact with us or start a collaboration, let us know. We'll find the contacts in the information below. Thank you so much.
Thank you.